Here is Neel Shah, a DevOps community guy, building various DevOps communities in my local region like Google Cloud, CNCF, Docker, HashiCorp, Grafana. Have mentored more than 15 plus hackathons, and yeah, a DevOps engineer. The first thing comes is I have all my data on cloud, so I don't emit carbon dioxide. Is that true? Let's think for a while. As we have hosted our websites on cloud, we have stored our images, videos on cloud. So where they are stored? They are stored in the data centers. And the data centers consume a lot of energy, a lot of power. So they do utilize the electricities and different powers. And yeah, they emit carbon dioxide, a lot of heat from that. So indirectly, you are also emitting carbon dioxide by let's understand how we can measure in our project and try to reduce them. So as we reveal innovations driven by software development, we also must undertake how much carbon footprint we are utilizing or having an impact in the carbon footprint of the environment. So what is Green DevOps? Green DevOps is a general terminology to implement carbon footprint and the efficiency of carbon footprint into the regular DevOps practice. It's integration of sustainable practice in software development lifecycle. Unlike the traditional development, where we focus on spread and functionality, and this kind of uh, cycle, we will consider the environmental considerations on the first priority and then the speed of functionality. So, yeah. That's just a change, focusing on the carbon footprint majorly, focusing on the environment firstly, and then everything comes that second. So here comes what are the benefits of green DevOps, reduce energy consumption. So first thing is optimize resources utilization throughout the development process. So we need to try to optimize all the things that we are working and try to lower the energy consumptions, and that will also help you to cut down your cost and also minimize the carbon footprint of your software development. Whatever you are building, just try to utilize lesser energy if possible. Not it's another thing like everyone will force you to do that. But yeah, lesser energy consumption anywhere will use lesser electricity, lesser data center storage. Everything will count and it will have an impact on the carbon footprint of the ecosystem. And eventually your cost will also be saved. That is also beneficial. Next is improve resource efficiency. So the first thing, some of the example which I can give definitely is when we use some of the VMs, and when we stop the VM, we forget to delete the disk which was attached to it. We forget to remove the static IP attached to it. Some of the things that we can do, and it will eventually help to lesser the resource utilization. Another one of the other example is we need to try to find out if we had taken 100 GB of storage and we are just utilizing 40 or 50 GB, then other 60 GB are wasted. So we try to utilize them in a proper manner. We need to monitor them how much we are utilizing on a like harsh day. If we are just going up like maximum to 60%, then yeah, we can eventually cut down it to 70 or 80% of the storage. That will eventually improve your resource efficiency and it will help a lot. Next is enhance software quality. You can also improve code utility optimization, infrastructure resizing that I already told, efficient testing process. So how the code optimization can help you? So when you have some functions running synchronously and it is taking a lot of time, so it will eventually take a lot of time to for data latency, data transfer sort of thing to come to the user and user. You need to improve that. Eventually, if you will improve code optimization, then the energy burst time, energy output, like, execution time, product execution time, function time will improve. That will eventually improve all the things. The code optimization thing which the developers can help you out, and we can try to implement that in our regular practices. So these are some of the things which we can implement in our regular life to implement some portion of the green DevOps portion in our regular life cycles of the product development. Next comes the GHG protocol. So there should be some standard to compare how much percentage or how we are emitting carbon dioxide. Eventually, for most of the products, there is ISO standard which is available, which is there for each and every product. Similarly, the GHG protocol, the greenhouse gas protocol. Yeah. So here comes the different scopes in which manner the carbon emission is there. The first is direct emission. So, and direct emission when we burn a coal, when we burn coal directly, then the amount of carbon emission of that is considered in the direct emission. Other is indirect emission related to purchased energy. When we purchase electricity, when we use electricity, the coal is burned or any other thing is done, then it is considered in the indirect emission. Other is other indirect emissions can be like business travel. So we are not purchasing anything, we are just buying a ticket of a plane. Yeah. Whenever a plane is running over there, it consumes fuel and also it will emit the carbon dioxide. So in same manner, there are different things which the GHG protocol has classified as the main major thing and most of the three scope. And let's see how that is classified in the DevOps. The GHG scope has if we store anything in private cloud, then it comes in second and third scope. When we deploy anything in public cloud, then it comes in the third scope. When we deploy an a hybrid cloud, then it comes in first and third scope. Similarly, for the if we just deploy front end, then it comes in the third scope. So similarly, you can understand how the carbon footprint impacts in the DevOps and where we deploy. It also matters in the private cloud, public cloud, or hybrid cloud. So this just a simple overview. You can go to Green Software Foundation and have more overview about this. So here comes the carbon intensity formula. So it helps to measure how much carbon utilization is used by you as per some of the ratios. So SCI equals E into I plus M whole equals per R, where all the things are energy consumed by software, energy carbon dioxide emitted, carbon emitted through software, carbon emitted through hardware, functional unit. This is how software scales. So per user, per app, per device, per unit. So per R is per R, per something per unit. E is energy consumed. I is the carbon emitted, and M is carbon emitted through hardware. The software is you can understand and this is a standard formula if you want to calculate the carbon intensity used by a product in a particular time and particular region. Then yeah, so this you can definitely do that. So and some of the major cloud provider also have their some of the tools which directly helps you out to get the amount of carbon footprint your resources are utilizing. For AWS, you have AWS carbon footprint tool. For Google, Google carbon footprint. For Microsoft Azure, Azure Sustainability Calculator. So most of the companies, most of the cloud provider are also helping to reduce the carbon as it will eventually help. to make the better environment for each and every person living on the earth. Another comes is this is the best thing which I love is cloud carbon footprint is an open source and free tool that you can make dashboards for free. You just need to sign up and make a dashboard considering your things. So yeah, you can see the dashboard like this, and it will eventually help you understand in a better way how your product, how your services are utilizing the energy and emitting the carbon. So next comes how we can reduce. We have learned what are the impacts, but yeah, we also need to understand how we can reduce in different manner. So first is cache static data. When we cache static data, the when the user requires the same data, so it will eventually take from the directly from the cache, not going to server. So it will cut down the load and it will eventually improve the software policies, software products, and also it will also consume less energy. Next is develop unused storage resources. As I already told, when we stop the VM, the boot disk attached to it doesn't directly delete. We need to enable that. So we need to delete the unused storage resources like that. Next is implement stateless design. So how to do that everyone knows. But why it is beneficial is when you run different functions asynchronously and synchronously, then what are the difference? When you run synchronously and if once the functions take a lot of time, you're supposed to take 2 seconds and it is taking 20 seconds. So another function after that which is attached to that takes needs to rest for needs to take a longer time, almost 18 seconds for more. So it is beneficial if you try to implement the functions parallelly, not parallelly, but yeah, after not dependent on everyone. That's the thing. Few non-urgent processing requests. So this is the thing. Don't do parallel processing sort of thing if not necessary because when we do parallel processing, it will take a lot of compute and it will also take a lot of CPUs. So when we do utilize serverless, so it will spin up more infra when we do parallel processing. So it is beneficial if it's not urgent, then you can queue the process one after the other. It will eventually do the same thing in the same infra with a smaller cost and also smaller energy. Scale down infra when not in use. You can also eventually do it with auto scaling policies. And also you can use serverless cloud services because it will automatically do this for you. Scale up and scale down when necessary. This is software to design. You need to consider making a software design properly. Software in production and development. This is choice of instance type. You need to understand how your utilization would be. Some of the things are on spot. Some of people may see reserve. So on spot majorly are preferred because as it will eventually use lesser storage and also lesser money. So it's beneficial for everyone. Get back to minimum auto scaling groups, containers, everything. Change the region or zone as per the software, as per the carbon emission rate in that region at the time if possible. Next comes cloud awareness. So how people can reduce it. Reduction is already there. But yeah, there are some other things which could be done. So first come is temporal shifting. Temporal shifting is when we have made a resource in a region where the carbon emission rate is reduced, sorry, at a scale up a lot. So we can, if it's possible, we can shift There are resources in the region where the carbon emission rate is lesser. So that's the thing. Next comes the demand shaping. So when we store videos, when we store images, so at that time, if we store the video, store the images in a lesser pixelate form, if the video was almost let's say of 10 MB, then we, if possible, then we can cut down it to 2 MB or 5 MB and then store to storage. It will eventually utilize lesser storage, and also it will eventually help you uh, to reduce the carbon footprint of that. Another good example can be given as if you run a Jenkins server, so CI/CD, and there are worker nodes. So some of the worker nodes are not needed now, then you can shift and postpone the work when the carbon footprint, the carbon emission rate is less. That are the thing. Next comes spatial shaping. So one of the good things is, let's take an example how the load balancer works. Load balance, if the user is in US region, then the load balancer will get the resources from the app or website deployed in the US region directly, not from the like other region of Asia Pacific or something. So in similar manner, if we can implement that, is the user should get the output where the carbon efficiency is good, then it will be beneficial. Google tried to implement this in one of the thing in the one of the recent reports. They found that 51% more carbon footprint was reduced. So yeah, that is a great thing. If we can try to implement this, not in a hectic manner, but yeah, slowly and gradually we can try to do this, and it will eventually help us to use lesser resources and also impact lesser on the carbon footprint. Next comes FinOps plus GreenOps. Is that true? When we are trying to implement GreenOps, that is like Green DevOps sort of thing, and also we are utilizing lesser resources, optimizing more of the things. Yeah, FinOps is also there. It will eventually helping the environment also and helping you. Connect with me for any queries. If you have, thank you. Have a nice day.